just
not
put it
equal
on.
to 12.
And 10 is hardly anything.
All right.
Yeah.
So,
No,
guys, already counting down.
No.
not counting today. I was doing
Is that the 24th?
Yes.
We've been counting that since like 8 days.
All right, so let's talk about hypothesis testing. Today we're not really going to get into actual testing, just kind of talking about the language, what it is. Then tomorrow we will start actually doing some of these tests and setting them up. A lot of what we do in the next few chapters, we are going to rely on our calculators quite a bit. So like most things, I'll show you how to do it by hand, but most of the time we're going to do our calculator. So if I said a friend wants to play a simple coin flipping game. If the coin lands heads up, you win. If it lands tails up, your friend wins. Suppose the outcome of 5 plays is 5 tails. Is your friend cheating? You guys think your friend would be cheating?
Yes.
Depends on who your friends are. I don't know. So what's the probability of getting a tails? 0.5 or 1/2. And how many did they get? 5. So we remember back in chapter 5 when we did that, it's like to the 5th power, or you multiply it 5 times. And if I do that, what's the probability? Does that mean your friend's cheating? Not necessarily. Is it likely? No. So I would say either our friend is very lucky, or is cheating. So then we're kind of looking at in this, like, how do I decide? Is there a way I can decide if my friend is super lucky or if they're cheating in this scenario? So we are going to do what's called hypothesis testing. So a hypothesis is going to be a statement regarding a characteristic of our population. So it might be about the mean, it might be about a proportion or a probability. But most of the time our hypothesis is going to be that something equals something. So for example, in 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. So we had something, so our hypothesis that we're looking at is that it has changed. According to a study in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. A researcher believes that the mean length has increased. So our baseline was 3.25. The hypothesis would be what? It's increased. It's greater than that. All right. This is what's called inferential statistics. We know descriptive is just describing what's happened, like finding these probabilities that we've been doing. We are trying to now take that and make some educated guess about what's going on. There's no need to do that if I actually know. If I know the mean length of a phone call right now, do I really need to go through this whole process? No. So this is only important if we don't actually have the population data. So if we're dealing with sample data and we're trying to make some generalization about the whole population. If you can get the population data, then you would want to go straight to that point. So hypothesis testing is basically the process where we have some kind of evidence and probability, and we are testing statements about a population. So the steps that we'll go through. We have to make a statement. We have to know what are we trying to prove. We have to look at our data for our evidence, and then we have to make a conclusion at the end. Based on this, I believe this or I don't believe this. When we go through it, it's going to be very concrete every time. So we'll start out with what's called a null and an alternative hypothesis. So we use H for hypothesis. The null is H sub 0. That's like our starting, our baseline. That's what we are testing. So if we have a previous study or something, that would be what we're going to start with as our null hypothesis. The alternative, we will call that H sub 1. That's what we are trying to find evidence to support. When we are looking through this, the null hypothesis is always assumed true.
Bonus points for getting it right or just attempting?
But it can cancel out like if they miss another one. Assume true unless proven otherwise. So we're always going to start at basically, assume this is the case. Can I prove it's not? The alternative is the thing that we are looking for our evidence to support. All right, so there's 3 different possibilities for how to set it up. The null is the same every time. The null is always going to be that our parameter is just the variable we're testing. So either like a mean or a proportion, something like that. Then our alternative, we can say it's less than that amount, it's greater than that amount, or it's not equal to that amount. So the alternative is the only difference. Not equal, we call that a two-tailed test, because if it's not equal, it could be higher or it could be lower, so both tails. Left-tailed is less than, so if we're trying to prove that it's smaller, that's called a left-tailed test. Right-tailed is greater than. So first thing we're going to do is just look at some problems. We're going to write the null and alternative hypothesis, and then we're going to state which type it is. So in 2008, 62% of adult Americans regularly volunteered their time for charity work. A researcher believes this percentage is different today. So my null hypothesis. First I need to know what variable am I talking about. If I'm looking at percentages, what are those usually? P, the proportion. And the null is always equal to. So what am I starting out assuming it's equal to?
62%.
Then the alternative would be what? It could be, but I just said different. So if I'm just saying it's different, it could be higher or it could be lower. So what do we call that? I didn't ask for it, but if I did, what is my parameter? The parameter is like the variable. So in this case, the parameter is P, the proportion that we're looking at. B. According to a study published in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. A researcher believes the mean length has increased since then. So my null, my H sub 0, what would it be? What's my variable? The mean. So null is always equal to. What would my alternative be? You are always using the same variable and the same number on both of those. It's just the null is equal, the alternative can be greater than, less than, or not equal. What do we call this one? What's my parameter? Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. So what is the null? Standard deviation, what variable is that? Sigma. So standard deviation was equal to 0.23. The alternative would be less than. What kind of test is that? And what's my parameter? Okay, so we're really not doing a whole lot today, just getting used to some of the vocab, null, alternative, parameters, left-tailed, right-tailed. Any questions so far? Are you good?
No, I couldn't get past the first problem. Can I get a pass? I'm supposed to have a pass
Are you coming back? Or,
for class time.
well, I
Yeah.
was gonna say if you.
I gave up. Could you say like 6 to like now? 6 o'clock in the morning. Just because it's Coach Kirby.
Do you wanna just, I mean, I can help you again in a second. Most of this.
I think it's going to take me a minute. Okay. I genuinely can't get past the first problem. I wasn't even close. Then I tried the second problem too because I skipped it and then I was worse. So.
If you're not doing anything in there, come back in and I'll help you some more. Okay? Okay. Let's look at this. The second thing we need to talk about is error. So we have two types of error. Type 1 and type 2. Basically, when we are hypothesis testing, we are trying to decide, is my null hypothesis true or not? And so we could make a mistake. I could conclude that my null hypothesis is true when it's really not. Or I could conclude that my null hypothesis was false when it's really correct. Those are the two types of error. So type 1 error is rejecting the null when it's actually true. So what I always think of type 1, you are concluding your null is true. So type 1, you conclude your H sub 1. Sorry, I said null, but I meant alternative. So in type 1 error, you conclude that the alternative is true, but it's not. For that, alpha is the variable that's used. So alpha is the probability of a type 1 error. When we reject the null hypothesis, we conclude the alternative, but it's incorrect. Type 2 error, we do not reject the null, but the alternative was actually true. So in type 2, you are concluding your null is true, but it is not. Because both of them are an error. They're a mistake. You did something wrong. For type 2 error, beta is the level for that. In almost every hypothesis testing problem that we will do, we will have an alpha level. And remember, alpha is probability of making a type 1 error. That's also sometimes called the level of significance. So the more serious our situation, the smaller we would need our alpha to be. So let's look at this one. For each of the following claims, explain what it would mean to make a type 1 error and what it would mean to make a type 2 error. So we're just trying to understand the difference between the two. So in 2008, 62% of Americans rarely volunteered their time for charity work. A researcher believes it is different today. So this was the same ones from example 2. So we already know our null and alternative. So type 1 error. What does it mean to make type 1 error? We reject the null, but it's actually true. So my null hypothesis was that the proportion was equal to 0.62. If you reject that, that means you went with the alternative. So what it means in type 1 error here would be we conclude the alternative, that the proportion, come on in, is not equal to 0.62. But we are wrong so we concluded that it's not, but it actually is. What would type 2 be?
I can't find that list. It only shows me the April 3rd. Oh, and there's April.
Okay, so type 2 is the opposite. We conclude the alternative, or sorry, we conclude the null, but it's actually the alternative is true. So we conclude the P is still equal to 0.62, but it is actually different. Okay, it seems like people really struggle with keeping these straight. So in both of them, they're an error. You did the wrong one. So just remember, in type 1, you are concluding your H sub 1. So type 1, we concluded this, but it was a mistake. So type 2 is the opposite. So if we look at the second one, what would be the type 1 error here? Type 1 is when we conclude the H sub 1. So it would be concluding that the mean length has increased, but we are wrong. So, but it actually didn't. So type 2 would be concluding what? Mhm. Do you guys understand the difference between these types of errors? In general, when we go through this hypothesis testing, we are never like accepting the null hypothesis. The null hypothesis, we are assuming it's true unless we prove otherwise. So if we fail to prove otherwise, it doesn't mean that I proved this was the case. Okay, it doesn't mean that I proved that, in fact, the mean phone call length is exactly 3.25 minutes. It just means I didn't have enough evidence to prove that it increased. So when we're going through these, our language at the end, we'll practice this a lot more tomorrow when we start doing testing. but you're never going to say, I conclude that this is true. We're going to say, we either have enough evidence to reject our null, or we do not. We're not proving it's true, we just failed to prove that it's false. Do you guys understand the difference between those? Okay. In general, as the probability of alpha type 1 error increases, then the probability of beta decreases. And in reverse, as probability of one type of error goes up, the other one goes down. Last one for today. According to a study published in March 2006, so the mean length of the phone call is 3.25. That's one of the examples we've been using. Researcher believes that it has increased. So, this is how we're going to practice wording our conclusions. Suppose the evidence indicates that the null should be rejected. How would we write our conclusion? So we would say, there is sufficient evidence to conclude the mean length of a cell phone call is greater than 3.25 minutes. So we had enough evidence to reject the null hypothesis. We don't think that's true anymore, so that means if the null isn't true, it's our alternative. So we have enough evidence to conclude that it's increased. If we get to the end and we have enough evidence to say that it shouldn't be rejected. Did I prove that the mean phone call length was 3.25 minutes? We didn't prove that it was, we just failed to prove that it's not. So all we can say is there is insufficient evidence to reject the null hypothesis. Doesn't mean that that is still the mean phone call length. It just means I can't prove that it's not. Any questions there? So I'm going to be doing this unit kind of like the last one. So we have a notes packet for the whole chapter, and I'm going to give you an assignment packet for the whole chapter. And we'll do a little bit each day. So you guys could probably finish the 10.1 today, but it's not going to be collected for a while.